Okie dokie. All right, functions. And again, for those of you that had lab yesterday, a lot of this will be like, I will be repeating the exact same things. So functions, raise your hand if you've passed grade 10 math. Yeah, okay, so you already know what functions are, great. You're familiar with something that looks like this, right? F of x equals x squared or something, right? Does that look spooky or does that look like familiar? Pretty familiar. We call that a function. What is the name of this function? F, right? Mathematicians are terrible at naming things. F. If I had another function, what would the mathematician call it? G of x or something, right? They always do that stuff, right? But they've named it f. This function actually takes it has one parameter, one variable in it, right? But notice that this is just the definition of a function. This just says, oh, here's a function, f of x is x squared. I can't do anything with this function until I say, okay, well, what's f of 3? What's the answer? 9. Right? So this is the definition of the function. And here, this is where we're using the function. And I only need to define it once, and I can keep, okay, what's f of 4? Oh, it's 16 or something, right? So that's the idea. You all have seen this before. That's all we're talking about today, but we're doing it with code. I'm going to show you syntax. I'm going to show you how you use it, but the general idea is the same. Okay, no mystery. If it was more complicated, computer scientists couldn't do it. So, like we talked last time about expressions and statements, once you have a bunch of those in series, we have scripts or programs, okay? But eventually you're going to find yourself writing the same chunk of code over and over and over again, or at least copying and pasting the code over and over and over again. But the trouble is, this is a pain in the ass. You can introduce errors easily, and your code becomes very difficult to maintain. And imagine you have this chunk of code, and you pasted it 100 times. And then you're like, oh, I need to change one value there 100 times. Okay? And then that's kind of a pain. And oh, there's got to be a better way. But there is, fortunately. We define functions just like that. Now, this is a mathematical one, but we can do ones with programming, the same idea. So we like to group together sequences of statements with a coherent purpose. We define a function in terms of a functional unit. This function does something. But it's an aggregate of a couple of lines of code that does something. Think of print. None of us wrote the print function. It was defined for us. Python gave it to us for free. So we didn't write it. If we were to go look and open up Python's print function and look at the code inside the print function, there's going to be a lot of code in there. It's a pretty complex function. But we use it by just calling print, and it does what we ask it to do. And it has one functional purpose, that is to display things to the screen, right? So there's a lot of stuff in there, but in aggregate, what does it do? It prints stuff to the screen. So in Python and in many other programming languages, we do all this whole thing with functions. So defining a function. So once you've defined a function, you can call it exactly the same way you would any other built-in function like print that we're used to in Python. So here's an example of a function. Okay? Now, you might say, why did you really break that up into two parts? Well, I did it to make the function look beefier than it is. But just give me a break. This is just a function. What is this function? Well, I am defining a function. This def is an important keyword. When Python sees def, Python goes, oh, this is the definition of a function. Then it says, okay, well, what's the name of the function? Well, it is Celsius to Fahrenheit. Okay? It has a parameter called temp in Celsius. The analog here would be Celsius to Fahrenheit, that's F. Temp in Celsius, that's X. And all of this is that. Okay? So, temp in Celsius, colon. The colon is very important. If you don't write the colon, it's going to yell at you. Usually Python's errors are going to be like, problem right here. But don't count on that all the time. So what does this code do? Well, we take temp in Celsius, multiply by 9/5. I save it in a variable. And then I take that variable, I add 32, temp in Fahrenheit, return temp in Fahrenheit. That's the function. Any questions about what we see right there? You'll also notice the indentation. That is critical. If you don't have it, it won't work. What does that indentation mean? Everything indented under this def is a part of this function's definition. This will be clear in one moment. So, yeah, the above is an example of a function being defined. What does this do? Well, it converts a temperature in Celsius to Fahrenheit. Sure, there's 3 lines of code, but what does it do? Its function is to convert a temperature in Celsius to Fahrenheit. The details of the parts will be discussed as we move through the topic, and you could probably already get a sense that it's a group of statements that serve a single purpose. It can be reused as many times as we want, just like that. So this is the definition of a function. I'm going to take this function definition. I'm going to copy it. I'm going to go over here. Let's reconnect. And let's just runtime. I'm just going to delete everything. This is from lab yesterday. We don't need it. There. All right. There we go. I put this code in, and I had to run it. I couldn't just paste this code into Colab. I had to paste it in and hit run, because if I don't hit run, Python's not actually going to know what's in there. So I pasted it in and I run it, and Python goes, oh, okay, so they've defined a function called Celsius to Fahrenheit. All right. Yeah, okay, cool. Now, given the function that's already defined, we can now call the function as many times as I want. For example, if I say Celsius to Fahrenheit 0 should give me 32. Negative 40 should give me negative 40. 32 should give me 89.0. Let's do that. Notice how I am unindented. I'm now back at this line here. To call it, I would say like print. Here, let's do like result equals Celsius and Fahrenheit. Someone give me a temperature in Celsius. 20. I heard 20. And then print result. There. Cool. All right. I don't need to do this in 2 lines. I can do it. I could do it like this. That's fine. So let's do that again. Someone give me another number. You said something over there? You said 27. Okay, someone give me another number. 34. Let's do another one. 8. And then one more after this. 16. Awesome. And so, let's get rid of these. We got extra lines here. Delete, delete. I hit run. We can see that those are all the answers. I define the function once. You only define the function once, and then once it's defined, you can call it as many times as you want. So there we go. I called it 1, 2, 3, 4, 5 times. I hope to see 1, 2, 3, 4, 5 results. Cool? Cool. The indentation is very important there, okay? Now, there's still a lot of stuff going on in here that we will discuss very shortly. But one thing I want to hit right now, and I will come back to this, is kind of like the flow of your algorithm. I said before, when you hit run, Python starts at line 1 and works its way down, and it runs everything in that order. Which is true, but we have to be aware about what it's doing when in that order. When I hit run, Python starts at line 1, and it goes, oh, they're defining a function. The function's called Celsius to Fahrenheit, and it takes an argument. Okay, great. And this is the stuff in the function, great. It just skips over that basically. It remembers that it exists, but we're not using it yet. In the same sense that we're not using this, we're just defining it. If I say, what's g of 7, you go, well, tell me what g of 7 is first. You have to define what the function g is. So here we define it. So Python goes, okay, this is the function, great. Okay, oh, okay, here, print what? Oh, Celsius to Fahrenheit 20. Oh, okay, they called the function Celsius to Fahrenheit. Jump up here. What value do you think temp in Celsius gets on this from this line? It's not a trick question. I bet my 5-year-old could figure this one out. Nothing? 20. Why? Well, because there's the 20. So this is a way to assign a value. 20 goes to there, and then 20 times 9/5 plus 32, yeah. So there we go. This gets evaluated, and then so on. So this goes here, runs, returns to here. We print out the result. We go here. Oh, jump back up here. Give the value 27. Go through, return to here, print it out, go down to here, jump up. So we're jumping all over the place, but it's in a very predictable, systematic way. How did I know it was going to jump? Well, that's how it worked. How did I know to jump to Celsius to Fahrenheit function? Because that's the function I told it to run. How did it know that 20, temp in Celsius should be 20? Because that's what I gave it. That's what's going on here. All right, so by the way, whenever you write a function though, like whenever you're writing any code, always test your code, okay? And test it with values that you know what to expect, right? Like these examples, like I knew that 0 is 32. I know -40 is -40 and so on. So it's always good to test your code once you write it. And how do you, well, you just run it. And when we call the function, Python executes the statements within the function in order that they appear. So functions allow for, like why do we like them? Why are we using functions? Well, one, they allow for reuse. You write it once, you use it everywhere. Maintainability, if there's a bug in the function, just fix the bug in the function and you're good to go. Readability is a big one that you might not be like immediately obvious, but like if I call a function called Celsius to Fahrenheit, there's no mystery. What is that function doing? Assuming you gave it a good name, oh, it looks like it's probably converting Celsius to Fahrenheit. Now, if you probably will recognize this now because we've been talking about converting Celsius to Fahrenheit. But like, I can imagine someone looking at C times 9/5 plus 32 going like, what the hell's that? Remember how like constants are great for naming a value? Functions are great for naming functionality. So C times 9/5 plus 32, yeah, a lot of people might look at that and be like, oh, that's convert Celsius to Fahrenheit. But I can certainly tell you that more people will look at the function called Celsius to Fahrenheit and conclude that that's probably converting Celsius to Fahrenheit. Would you agree? So readability is good too. And so, yeah, and then finally, it facilitates abstraction. And abstraction is going to be this idea we keep coming back to this semester. We already talked about it before, especially when talking about, like you might remember how when I was talking about that like making breakfast example, and I started to be really nasty about like, well, how do I lift my arm, right? Or like, how do you make pasta? Well, you know, if you're another human, you could usually say, boil water, you know, have the pasta in there, add some salt, boil the water, wait till it's like, 8 minutes, and you're good to go. But if you were to tell that to like a robot, you'd probably have to be like, okay, get pot, put pot in sink, turn on water, wait second, turn off water, right? Like think of the number of steps. They're both achieving the same thing, but they're described at different levels of abstraction. Think of the print function. Do you have any idea of how that print function works under the hood? No, you don't. But can you use it? Yep. So did it matter that you didn't know how it worked? No. Sure, it might be great to learn how it works. Who here can build an internal combustion engine from scratch? No, you can't. But I bet you can get in your car and drive. Did you need to know how an internal combustion engine works entirely? How every piece of your car works in order to drive here today? No, it didn't matter. Because you interface with your car at a very high level. Steer, on, off, transmission, pedals, blinkers, whatever buttons else you got, right? That's how you interface with it. There's a lot of crazy stuff going on under the hood, but that didn't matter for you to use it. So we interface with the car at a high level of abstraction, where under the hood, there's a lot of crazy stuff going on, but it's like hidden from us because it doesn't matter for its utility. Okay? So let's do a quick activity. Write any function you want. I don't care. Make it do whatever you want. Write it and call it. Make sure you get it working. Make sure you can write a function and run it and make it do what you want it to do. Go do that now. I'll give you 3 minutes for that one. What's up?
Do parameters work in the same way the input did?
No. So the parameters, when you call it, you would say like, you say Celsius to Fahrenheit and you put like 7 in there, right? So this eliminates the need for like an input. But like you can think of it as an input because like that's kind of like the input to the function and the return is like the output of the function. But don't think of it as like input to the computer and output of the computer because the input function is how you added data into the computer. And the print is how data from the computer was output to you. Where the function, it's still all within the computer, but like when you call it, like you can put whatever value you want, and then that it's effective. That's just a variable, right? So when you call it, you put in 20, temp in Celsius takes on the value 20 that time.
Okay.
Yeah, just once you play around with it more and we get through this topic, I'm willing to bet you'll kind of have it. Yeah. What's up? Yeah.
When you put these square brackets into my sum function
Yep.
yesterday, what did they do?
So what it did is it turned it into like a literal list. So sum has to work over something that's called iterable, meaning like it's a collection of pieces of information, and a list is a collection of pieces of information. So when you had it as just 2 values, it was saying I can't sum those things, right? I need it to be like a collection of things I can sum. So I just wrapped it in the brackets to make it a collection of things such that it just shut up. Now, remember, like, and that's just how the sum function works. Why? Because whoever wrote it that way. Don't blame me. That's yeah. It's my fault, I know. And this is going to be on this recording is going to be on the video, but yes, but that's what it was doing. Yeah.
Thanks.
Cool. Did everyone write their function? Who needs like 30 more seconds to finish their function? Okay, yeah, take it. What's up?
I've jumped ahead a bit, and I just want to make sure that this is kind of correct. This is a good way to check, or is there supposed to be like brackets or anything else there?
No, that's fine. We could start to have a conversation about like sameness and whatnot, but that's a conversation. That's yes, that's fine. Yeah. Yeah, it's good.
Just go to you don't keep going down the road from Mall. Oh. You go to the Infield Center, come to the store, there's a cafe, food's good, you leave the meal swipes there.
All right. Def, this is a function. And what am I going to make it do? A and B, return A plus b to the power of 1/2 or something there. And then print 1, 1. Nope. Let's do 2, 2. Cool. All right, there we go. So here's my function. It's a simple little function. What am I doing? It doesn't matter. The point of this is I just wrote some function. How did I write it? Def. I give it a name. I give it some number of parameters. The one I showed you before only took one. Oh, well, it was there. The f of x only had one. But actually, by the way, you can have really as many as you want. Colon. And then whatever's in here. I only have one line of code. This return keyword, which we will talk about shortly, and some calculation. It doesn't matter. And then I called the function 3 times. That's it. Who thinks they can win the competition of who wrote the weirdest function? What did yours do? Now you're not sure you want to share?
Well, it definitely wins.
What does it win? What does it do?
It gets a variable as a percentage and spits out a message.
I'm sure it's a very friendly message. Yeah. Okay. Yeah. All right. Can anyone else win? Yeah.
I have more of a question.
Yeah. What's up?
When I did the area of a square.
Okay.
So it's just whatever I input squared.
Yep.
And it doesn't work. And then I put like data input or like whatever at the top, and then I run it, and then I put it in the middle, and then I run it again, and it works. But it doesn't work before I put it at the top and then in the middle.
I'm not 100% sure what you mean. When you said data input, like, did you use the input function?
Yeah.
Okay. So there's nothing stopping us from using the input function, but we really don't even need to worry about the input function. Just define it and then call it with whatever hard-coded values I have here. That's all we need to be worried about right now. So I'm going to do what you are describing. Okay? I'm going to go down here and I'm going to say def area of square and x. Or let's get it like side. Right? That's a good variable name. And then area equals side times side, because why not? I guess I could do like side squared, right? There, right? And then return area. So this is just the definition. Now if I want to know, I can go print area of square 5. 25 looks good. Now what we could do is if you wanted the input, which by the way, in general, we're not going to do this in the class, but let's do it for fun anyways. Let's do input, some value equals, let's assume it's a float, I guess. Okay, so now I could do like some value like that. I hit run, and I say like 6, and I get 36. Okay, cool. Right? So this is doing what you wanted to do. Now, what about what I have is different from yours? I think I knew what you were saying. I just want to make sure I have it right. Was it that you had the function defined somewhere else?
Can I just come show you?
Sure, let's go have a quick look. And I want to see because I want to show everyone.
Okay, here I have, so here it works, but when I just write it like this, okay, well I put this one as a float and I put this one as an integer.
Well, whatever, that shouldn't
but,
matter.
You know, but okay, when I write it like this, it comes out and says, what? But when I write it like this and then I copy and paste this into here, then it works. But I just have to run it once before with it up because I did the pre-lab and this is how I did my pre-lab.
Okay, hit run on that one. So what's the problem with this one?
It works.
Okay, yeah, it looks good. And then do that one.
This one also works because I put this
Inside, not outside.
Well, I put this up here and then wait. I'm actually gonna look really dumb if this works.
Well, let me see.
You're good. Oh. I don't know.
Okay, well, you know what? I will talk about this, and we do cover this in the lab today. So if you had lab yesterday, you would have heard me talk about it. So, in general, so this input here, which we're not really going to be using a lot in this class, but this input here is a way for you to input data into the computer, and print is a way for the computer to output information to you. Parameters are how you can input information to a function, and the return is like the value that's coming back out of the function, but more on that in a moment. These right here, when you do input-output, like in general, functions, and like all the functions that you're used to in math are what we call like pure functions, which has some crazy meaning. Long story short, the functions take input, produce output, okay? Now, the input function is kind of interesting because the input, maybe let's talk about print. Print's interesting. That A equals print? A. Okay, yeah. So functions can take input and produce output. But when I say a function's producing output, I don't mean the fact that like print displayed the number 25. I know it's outputting from the computer, but that's different. That's what we call a side effect. Like area of square takes a value. So if I'm going to call it like AOS, I put in 5, it gives me 25, right? Input, output, right? When I called print, like whatever, input, it didn't actually give me output. It actually gave me none, which is a fancy way of saying nothing. It didn't give me output. That's why we see like a none here. Give me a moment. But it had a side effect. That side effect is, it displayed text to the screen. So it's like an impure function. It has a side effect, which is fine. There's nothing wrong with that. It is what it is. When I talk about pure function, side effect, mutability, blah, 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 these are relatively advanced ideas that new programmers, you really don't need to be too worried about. But I am talking about them currently because if you become experienced programmers, and let's say you're writing software or code to do whatever, there are reasons why you might want to like avoid side effects. Side effects are tricky, they're hard to wrap your head around, they're difficult to test. There's a lot of reasons why, and they scale weird. There's a lot of reasons why side effects can be tricky. But when you're a new programmer, that's not obvious. So if you're thinking, well, how am I supposed to know side effects are a problem? You're not, but I'm telling you now, and I'm going to be telling you things about like how to write code good, where the motivation for what I'm saying is kind of hard to motivate at this stage, but I'm letting you know now to help you develop not bad habits at this stage. Again, it's not that it's intrinsically bad, but there are some reasons why you might want to do some things a certain way. So why did I just rant about that? In general, doing it where you have like an input-output, so like I wrote the input-output here. Oh, actually, okay, let me finish this before I talk about input-output in the function. What is this none here? Well, if you were in lab yesterday, we absolutely talked about it. So spoiler for those in lab today. When we call a function, functions, I know I just said print doesn't return anything. Well, actually, every function must return something, whether you like it or not. And if your function doesn't return anything, Python secretly and goes in sneakily and adds a return statement for you. And it adds return none, which means return nothing. So it returns something that means nothing, which is weird. But long story short, we call this function, it returns none. None gets stored in A, we print out A, we see none. It's weird, it is what it is. We'll talk about it more in lab. If you saw this yesterday in lab, you heard me rant about it. We'll talk about it in lab today a little bit more anyways. All right, so let's get that out of the way. We do this, 55, okay, great. Cool. So, in general, like input, output, very side effecty. But area of square is what we would call a pure function. It has no side effects. And we kind of like that. We could do this, where I do this, I go like that, I do some, oh no, I'll change this to side, and then here, instead of return, I can just do like a print, like that. Oh, and I got to call the function, area of square, but now it doesn't take any, like there's no parameters now. I got rid of the parameter, I hit run, and you're going to see it does the same thing. Oh, what did I do wrong? 77, one was give, oh, that's why, because I should say area. There. 55, great, right? It's functionally the same. And you might say, yeah, you told me I like to write functions that have like functional units, and the functional unit is like, get some data from the user, do some calculation, and print it out. That's part of the functional unit. You are right, but in general, it is good advice to not do it this way. Any side effect, and for us, I'm pretty sure the only side effects we're really going to be talking about at this stage of the semester are just input-output. All of your input-output that your code does, it's better to not have that take place inside functions. It's better to have that take place at like the top level part of your code, basically the most unindented part. And if you're like, but my function really does need to get input, get the input, pass it to the function with parameters. I really need that function to print something out. No, you don't. Have it return the value, and then do whatever the hell you want with the value that's returned, like print it out, or what else? But the point is, ideally, you kind of want to not do it this way. If you do it this way, you're not going to get in trouble here, okay? If you get a job in industry and you do it this way, maybe someone never even says anything to you. But in general, don't do it this way. It's better to do it this way, where get all your input output here, or get all your input, pass it to the function, get the value back, and then print it out. That's really how we want to do it. It's just better that way. If someone wants to, it would be hard for someone to make an argument against that, but like, are you breaking it? Like, is this a sin? Are you breaking a rule? No, but you kind of, it's just, trust me, you don't want to do it with side effects. Cool? So I realized that was long-winded, but I think it was good that you asked that question because it gave me a chance to kind of go on a little rant about that. How would you have known this? You wouldn't have. I'm just telling you right now, you're probably going to make this mistake. It's not even really a mistake, but you're probably going to do it the wrong way a lot in this class, but that's just, you're learning, right? So it doesn't matter. Just try to follow good habits. Okie dokie? Any questions about that little rant? All right. Okay, function parameters. So notice that Celsius to Fahrenheit had a parameter called temp in Celsius. Or here, it has a parameter called side. This one right here, this is a function that I have, it has two parameters, A and B. I can have as many as I want. Though, be mindful, like if I accidentally give it 1 and it needs 2, it's going to say, I'm missing 1. Or if I give it too many, like 2, 4, no. Weird. Huh? Oh. I'm going to run, it's going to be like, it takes 2, you gave me 4, so like it matters when you call it, but you can have as many as you want in there. There's even ways to make it like variable length, but that's a whole other thing. So why do we have these parameters? Well, imagine for a second I wrote a function. This is a silly example, but I think it demonstrates the point I want to make. For example, it would be really silly to write a function 20 degrees Celsius to Fahrenheit, where all it would ever do is convert 20 degrees Celsius to Fahrenheit. And then someone comes along and says, like, okay, well, what about 30 Celsius to Fahrenheit? And then you go like, okay, I'll make a function called 30 degrees Celsius to Fahrenheit. And then they come along and they're like, okay, what about 31 degrees? And you're like, okay, I'll write another function. Wouldn't it be better to write a more general function that can take some variable value, some value that I can like tweak however I want as input, and it give me the correct output, right? Because otherwise, I'm going to have to write like a bajillion versions of this function. That's stupid. Why would I do that? I will use these parameters to generalize these functions, make them much more useful for us. Right? So instead, we write it once. Yeah. So here'd be a really silly version for a variety of reasons, but like 20 times 9/5, and then whatever time plus 32, return 10, like that's silly. I'd have to write a lot of these functions if I wanted to do it this way. Think of print. You've used print before. Print has a parameter, right? Well, what's the value you want to display? There's not a billion different prints to print every possible combination of things you might want to ever print out. No, there's one print that can take whatever value that it gets printed out. Cool? Cool. So that's why we have them. So in reality, this is not a new idea. All of this is not a new idea. You've been doing this since at least grade 10, right? Here's a function, f of x equals x times 9/5 plus 32. Right? And then, oh, what's f of 20? Well, it's that. What's f of 30? Oh, it's that. This is the same thing, exact same thing, just written slightly different. But what does it mean? The same thing, which is pretty cool. I've been saying this a lot lately, but raise your hand if you kind of don't like math. Be honest. Yeah, I got bad news. And the bad news isn't that there's a lot of math here. The bad news is that it doesn't look like math. But I'm sneakily making you do math. Not just because this is explicitly like algebra, but like programming is math. It just doesn't look like it. Don't worry, I fell for the same trick too, right? Next thing you know, I was like, wait, this is all math. When did this happen? And then it's like, well, it's too late now. That's what I'm doing. All right, so execution of a function. So let's say I've got some function called square of sum. Okay, so it's going to sum two values together and return the sum. Okay? Here, if I call the function square of sum 2, 3, Python will, like let's say I call that function. Python will first check, do I know of a function called square of sum? In this case, we have it defined, so we do. So Python goes, okay. If it wasn't defined, Python would say, I don't know what that is. Right? Hey, Python, go build a train. Python's going to say, what? You have to tell me how to do that first, right? It doesn't know. So it knows what it is, and then because I called square of sum 2, 3, what'll happen is it takes the 2 and it takes the 3, and it's all positional. So the 2, because it was first, gets assigned to A, and the 3 gets assigned to B. It's just like variables, okay? But instead of assigning the variables like A equals 2, B equals 3, you do it through this syntax. You pass the values in there, and then it goes up positional, and then, oh, A becomes the 2, and B becomes the 3. That's how it works. By the way, these are called parameters. Like the variables here for the function are called parameters. These down here are called arguments. It doesn't really matter that much. Almost all computer scientists and programmers are going to use these words interchangeably all the time. It's a very abused set of words. Everyone knows what you mean in the context. If I said, oh, the parameter's 2, 3, you know what I mean. Okay? But I'm just pointing out that technically there is a difference. These are called arguments. The values that get passed are arguments. The values as defined as variables up here in the definition of a function are called parameters. So there is a difference. I do my best to get it right all the time, but I'm going to mix them up all the time. Everyone does. But there is actually a difference, by the way. So yeah, that gets it. And then what happens in here? Well, A and B are added together. It gets stored in C. And then C times C, it gets stored into D. And then we return D. Now, that return is interesting. Return is what you call a function. It does its thing. And then when it gets returned, it returns the value to wherever the function was called. Let me show you what I mean. So here's how this worked. Python starts, says, oh, there's a function definition. It takes two values, does some returns a value. Great. ASD. Okay? It calls square of, here, let me put in numbers that I can do in my head real quick. 2 and, 1. There. Cool. So what's happening? Okay, Python goes, okay, great. Yep, yeah, sure. Oh, finally a line of code I can run. Okay, oh, there's an assignment taking place. Well, we always go to the right-hand side of the assignment and evaluate what's going on over there. So sum of squares, oh, that's a function call. 1, 2. So jump up to that function. Oh, here it is. So Python's execution, this is how it went. It went dot, 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 dot. Oh, back up to here. A is 1, B is 2. A, 1 plus B, 2 is 3. C becomes 3. 3 times 3 is 9. D becomes 9. Now we see return D. We get to this line. Python returns to the line that called it. Now, in this particular case, the line of code that called it happens to be the next line here, right? That doesn't need to be the case. I could do something like, right? So whatever, great, we go here. Okay, now it does the calculation. Return D. This value, 9, goes, and effectively, this function call evaluates to the value that was returned, the 9. So what value gets stored in the variable ASD? Uh-oh. So what value, I call sum of squares 1, 2, what value is saved in the variable ASD? Yell it out. I'm seeing people say it. Trust yourself. What value is there? 9. And then what do we do with it? We print it out. So we see 9. Great. So the parameters are how we put values, or the arguments is how we put values in, and the return is how we get values out. And we'll start there again next time. All right, I'll see half of you later today.